This lesson shows how to graph the rational function x squared minus 4x over x squared minus 9. In previous lessons, you've learned about the four important parts of a rational function. The vertical asymptote is a vertical line where the function is not defined. The graph curves up or down as it approaches its VA. The horizontal asymptote is a horizontal line the graph approaches away from the VA, curving down from above or up from below. The y-intercept is where the graph crosses the y-axis, and the x-intercept is where the graph crosses the x-axis. This lesson shows how to graph the rational function y equals x squared minus 4x over x squared minus 9 and variations of the function. The VAs are the zeros of the denominator. The factors of the denominator are x plus 3 times x minus 3, so the function has VAs at x equal negative 3 and x equal positive 3. For this rational function, the numerator is degree 2 and the denominator is degree 2. Since the degree of the numerator is equal to the degree of the denominator, the HA is the ratio of the leading coefficients, which are 1 over 1, and that simplifies to 1. So the HA for the function is the horizontal line y equals 1. To find the y-intercept, evaluate the function for x equals 0. This gives 0 over negative 9, which is 0. So the y-intercept for the function is the point 0, 0, the origin. The x-intercept is the 0 of the numerator, so this is a good time to factor the numerator. To find the x-intercept, set the numerator equal to 0 and solve. Since there are two factors in the numerator, there are two x-intercepts, one at x equals 0 and the other at x equals 4. Next, calculate at least one point on either side of both VAs. Starting at the left, for x equal negative 4, y equals 32 over 7, and there's a point approximately at negative 4, 4.6. For x equal negative 2, y equals 12 over negative 5, and there's a point at negative 2, negative 2.4. For x equal 2, y equals negative 4 over negative 5, and there's a point at 2, 0.8. Finally, sketch a graph of the function. From this point, the graph couldn't curve down because that would create an x-intercept, so the graph must curve up towards the VA and down from above towards the HA. From this point at x equal negative 2, you can see moving to the left, the graph is decreasing, so the graph must curve down towards the VA. From this point at x equal 2, you can see moving to the right, the graph is increasing, so the graph must curve up towards the VA. Finally, from the x-intercept at x equal 4, the graph must curve down towards the VA and up from below towards the HA. And so the graph of the function looks like this. If you multiply the function by 2, the graph stretches vertically. For example, notice how this branch of the function is higher, and the HA is now the horizontal line y equals 2. If you multiply the function by 1/2, the graph shrinks vertically. For example, notice how this branch of the graph is lower, and the HA is now the horizontal line y equals 1/2. If you multiply the function by -1, the graph is reflected vertically. For example, notice this branch of the function is flipped over from the second to the third quadrant. If you change the factors in the denominator, you can shift the VAs. For this example, there's a VA at x equal -2 and x equal +1. In this variation, the x minus 3 factor in the denominator is changed to x minus 5, so that both x-intercepts are between the VAs. If you change the factors in the numerator, you can shift the x-intercepts. For this example, the x-intercept at x equals 0 is shifted to x equal -1. In this variation, the x minus 4 factor in the numerator is changed to x minus 2, so that both x-intercepts are between the VAs. This lesson showed how to graph the rational function x squared minus 4x over x squared minus 9. This lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.